Okay, now this is the last module for module 2, that is 2.3, Maxwell Boltzmann statistics. We will not waste so much time on this. The outline will be the Maxwell Boltzmann statistics, variation of W with average energy. W is the most probable configuration. Now we'll look at this Maxwell Boltzmann statistics. In the Maxwell Boltzmann statistics, particles of the ensemble are considered distinguishable. So consider a macro state large assembly of n atoms with total energy E. For a particular configuration of this assembly, let n1 atoms belong to state 1, n2 state 2, n3 state 3. Now this is our thermodynamic probability, which we have stated before. But n is very large, therefore W will also be very large. So we can treat W as a continuous function. In fact, every other thing we do from here now will be mathematics. And we will not bother you so much because some of us did not do further mathematics. For those of us who did further mathematics, will understand proper, but just understand the significance of what we arrive at. So when we treat maximum, when we take W as a continuous function, then we'll take natural log and we'll get equation 2 and 3. We go further to use Carlin's approximation. Now calculate, bearing in mind our restrictions, the summation of Ni, which is equal to n, is constant, and of course the summation of energy is also constant. We do that and use the method of undetermined multiples and calculate to get equation 7. And then when we go further, what is important to us is equation 9. This equation 9, and that is what we call the Maxwell-Boltzmann distribution law. These two equations gives us the Maxwell-Boltzmann distribution law. And they give for any system the number of particles which will possess the energy EI in that particular configuration, the equilibrium state of the system. And Q that is there is very important. It is called the partition function. This Q plays a very big role. Both the first and second derivative of this Q can be used in the interpretation of entropy, which is above this level where you are. So we don't want to bother you with, using the partition function in terms of interpretation of entropy of the system. Now, variation of W with average energy. We still use the same principle of the most probable configuration, thermodynamic probability, and then we'll take natural log and we'll also put the same Stalin's approximation and we'll arrive at equation 14, which gives us that E is equal to half KT, and therefore E will be equal to half beta, where beta is equal to 1 over KT. Therefore Q, our partition function, is summation of Gi e to power Ei over KT, where Gi is the degeneracy of the state and K is the Boltzmann constant. This is just the equation 15, is a very important equation when we start talking about this variation and how to get a partition function. Now in the Bose-Einstein statistics, there are other types of statistics which we are not going to look at here. In the Bose-Einstein statistics, the particles are considered indistinguishable, and there is no restriction on the number of particles that occupy any energy state. Remember, we had a restriction of constant n and constant energy. And then in the Fermi-Dirac statistics, that's the FD. In the Fermi-Dirac statistics, applies to indistinguishable particles that obey the Pauli's exclusion principles, if you still remember, according to which there can be no more than one particle in each. Pauli's exclusion principle is telling us the number of occupation states, gives a restriction to the number that can occupy any particular state. Thank you very much. We have looked at Maxwell Boltzmann statistics. We don't want to bother you with a lot of equations. We are just interested in the partition function and the mathematical statement of Maxwell Boltzmann distribution law. And we have also looked at thermodynamic probability, the variation with average energy. And this brings us to the end of module 2. we will go to module 3 when we will give you time to go through this and understand. Then we'll go over to module 3. Thank you very much, and keep striving to learn. Keep striving to learn, and God will help you to acquire the knowledge and do well in your studies. Thank you very much, and God bless you.